We are going to begin our study on logarithms today. So this is going to be an introduction to logarithms or logarithms. So you might be wondering, what the heck is a logarithm and why is it in here with my interest equations and my half-life and my population growth? Well, you've certainly may not have come across, you certainly will come across problems that you can't solve with exponentials. So So logarithms were created. Yes, I did say created. Uh, they were created to be the inverse of exponential functions, which means they undo an exponential function. It's important. I think it's important for you to understand that math was not found under a rock. Okay, somebody didn't stumble over a rock like, hey, look, there's math. Let's pick it up. Okay, no, math was created to make sense of things that happen in the world, to create some order to the chaos that is perceived going on around us. Like, why does the sun, why is it rotating around the Earth? Better speaking, is why is the Earth rotating around the sun, and how long does it take? Math and geometry and all that stuff was used to figure out the amount of time it takes to set a clock, to set a calendar, all the stuff involved in math, and math had to be created to make sense of things that were happening. Okay, and it's helpful. I mean, whether you see it or not, math is something that's helpful. Borrowing money, you need to know math. You need to know what you're paying, or you need somebody who does know it so they can tell you how to do it. So bottom line, they were created to undo logarithm functions. So we're gonna first define what a logarithm is before we can get into how to use logarithms. So a logarithm has a very interesting definition, and it helps to know how to say this statement right here. This is written like this, and it's said log of x base b equals y, or log base b of x equals y. So two different ways to represent verbally this equation. Now this is the rest of the definition. This statement is true if and only if b to the y equals x. So that's pretty important there. I'm gonna highlight that for us because that is something that we definitely want to have written there. And I noticed a little bit of something disappear here. That should be b to the y equals x, and that's an equal sign there as well too. So I got some stuff disappearing on me. Bear with me here. I'll try to catch them all. At any rate, this is important to recognize. So let's look at an example. What does that really mean? Well, log base 2 of 8 equals, that's called a y. And again, this can be any letter we want. This is generic up here, right? X and y are generic. B is pretty consistent for base. So based on our definition, this statement is true only if this is true. So that means that 2 to the y equals 8, which means 2 to the y, well, 8 is 2 cubed. And we know our rule, our law, remember, look after that, exponent lawman, y has to equal 3 in this case. So that's how you can use a logarithm. And this logarithm right here was considered a log with a base of 2. Okay, that is a log base 2. This would be a log base 3. I'm going to show you some examples here real quick on the calculator for what to look for, but keep on this page for now. This, oddly enough, right here, let's throw a number in there. This is a log base 10, which is the common logarithm. And that's something you want to commit to memory. The common logarithm is something we'll use most often. And this guy right here, with that, yes, that's a letter. Oddly enough, the letter E, which represents a number, is represented as ln. That is the natural log, or the logarithm naturel, if you will. So the reason I popped the calculator open over here is because if you look closely on our calculator, we have an ln button and a log button. And if you look above the log button in blue is the 10 to the x button. Okay, that's because we always have on our calculator the inverse is written above the key. Okay, and you have plus with the minus, times with division, tangent, inverse tangent, cosine, inverse cosine, stuff you don't quite know yet. X squared and the square root, log, 10 to the x, natural log, and e to the x, which we mentioned briefly a couple videos ago. So this stuff is all important to know as far as a log is concerned. We'll also briefly look at the graph of a log in case you forgot about it. Okay, remembering that a log is the inverse of an exponential. Okay, this graph will now change. Instead of being in the first and second quadrant, this graph now looks more like this. We got to reflect it over. Instead of crossing at 1 here, it crosses at 1 on my x-axis. Okay, and recall that the domain is 0 to infinity, and the range is all real numbers, whereas our exponential, right, this is log base b of x, and this is, we'll just say b to the x. Okay, whereas the domain here is all reals, and the range is 0 to infinity. Notice the domain and the range switched with domain range, and that should make sense because inverses you switch x and y, correct? So that's a little bit of logarithm there for you there. Talked about the definition, and that holds true for every base of a logarithm. In other words, if I tell you that log base e of x equals 5, that means e to the 5th power equals x. And remember, this log base e can be written as the natural log of x equals 5. It still implies the same thing. It's just one of the ones that is used so often it was worthwhile to come up with a different way, a quicker way of writing it. You might find it interesting to do an internet search of where are logarithms used. Where are logarithms used? And undoubtedly you will find many instances where logs are used. So for instance, we've been doing a lot with interest where we've known the time and we've known the rate. Well, you can find out the rate. Okay, so in interest and mortgages and finance in general, you can figure out the rate by using a logarithm if you know the other information, as opposed to needing the rate to find the cost. It's also used in intensity of sound, intensity or volume. It's used in calculating the magnitude of an earthquake. Magnitude of an earthquake. And I'm sure several other things if I would take a couple more minutes to think about where it's used. But some pretty neat examples there that I use pretty often with sound and interest and magnitude of an earthquake. So bottom line, through all this, remember the definition of log right here is our big guy. All right, so that'll help you with some examples. In the next video, we'll talk about some properties and laws of logs. So if you know this guy right here, you can do anything right there. Nice to have you. Signing off.